Okay, here's an example where we have a vector field that we're trying to find the curl of. So my f here, I have sine of yz I, e to the xyz j, 13 plus 7zk. And I want to find the curl of f. Well, the curl of f I know is this del cross f, where this del here is partial respect to x, partial respect to y, partial respect to z. And so to do the cross product, we make a matrix here. So we're going to have I, j, k here, partial respect to x, partial respect to y, partial respect to z. And here we have a sine of yz. Here's an e to the xyz, and here is 13 plus 7z. So I want this determinant there. Well, so what we get here is we're going to have I times partial respect to y, partial respect to z, e to the xyz, and I have 13 plus 7z minus j, and then we have partial respect to x, partial respect to z. We have sine of yz, and then here we have a 13 plus 7z, that one, and then plus, I do this for k, I have partial respect to x, partial respect to y, sine of yz, e to the xyz, and this is with k. So it's just like taking a cross product of two vectors, but in this case we're looking at this symbolically here. But we have the first vector crossed with the second vector. So if you know how to do cross products, you know how to get to this step. And now what we're going to do is we're going to expand each of these. And so we're going to have now, and I'm going to write the I and j and k at the end here. So I'm going to have partial respect to y, 13 plus 7z, minus partial respect to z, e to the xyz, so that's I, and I have minus, and then partial with respect to x, 13 plus 7z, minus partial respect to z of sine of yz, j, and then plus, I'm going to have what on this guy in here, I'm going to have partial respect to x, e to the xyz, minus partial respect to y of sine of yz, k. And now for our final step, we just have to evaluate these partial derivatives and write this as a vector. So this guy here is going to be 0, and then with respect to z, my x and y look like they're fixed, and so I'm going to get negative xy e to the xyz I. Okay, and then on my j's here, partial respect to x of this has no x in it, is 0, and then here I get cosine of yz times y because I'm using the chain rule and y is held fixed there. So this is going to give us plus y cosine of yz j, and then finally on our k's here we're going to have plus, in here this is going to give us what, yz e to the x, y, z minus, and then I have a z cosine of y, z, k, and you can see it there. That's the final answer right here. And we say this is a non-zero vector field, so our f here isn't conservative.